All right. So I I didn't coin it, but I really like saying it. Big fat happy data. This kind of goes over a very shallow aspect of what I consider to be big fat happy data, which is actually, instead of using relational databases and then normalizing all of this information through tons of different tables, you actually keep relevant information right next to each other on the same disk sector for the most part, and then you just grab it, parse it, do whatever you want with it. Now that we are looking more at object-oriented systems and being able to map data into classes. So I will actually go into that now. Who am I? Real quick. I already said a little bit about that earlier, but I'm a MongoDB geek and evangelist. I've been doing that for about 2 years, and I also have a lot of experience with MySQL and Postgres. I say MySQL. I can't stand SQL. I first got interested in MongoDB when I was working on a very large-scale information system called Informatico that indexes and searches just about anything. And it was an internal project where I was working, and ever since then I've kind of had this slight love affair with it, and really it biases my opinion on a lot of things. Oh yeah. I'm not going to talk about the short walks on the beach. What else did I say? Well-lit dinners. I actually, I'm kind of colorblind, so I'm kind of careful with my beef. Who are you guys? So whatever your experience is with Mongo, or whatever your experience level is with SQL or MongoDB, MongoDB itself is simple to download, install, and start mucking with pretty easily. When I say no SQL, I mean database systems that have their own query language, query system, query functions, query anything that doesn't necessarily stick with the SQL standard, which has with it a ton of weird mentalities. What's that?
Like access.
No access. Access is like SQL light.
It's like SQL wrong.
SQL wrong. All right.
Access. I'm doing a.
He's abusing information technology as we speak. So this is kind of a scenario presentation. So what's involved? We have two databases. We have MongoDB, which is a schema-free solution. And what I mean by that is you look at objects in the database as documents with arbitrary information in them, and you can assign indexes to that arbitrary information. If you don't know much about indexes, then that probably just flew right over. That's okay. Indexes are awesome. This schema-free design also moves a lot of the control over to the user, and this becomes incredibly vital when you're upgrading, when you're making changes to your database. When you don't really want to take one database and completely rewrite it to use a new schema, you actually use a schema-free design, and then you develop your upgrade potential through it instead of expecting everything to just crash horribly every time that you make a slight change. MySQL, on the other hand, is standard compliant, yay, and a base solution that uses SQL. So the scenario situation that I'm looking at is we're just going to aggregate or total the Linux-oriented Twitter updates per city, district, or region, as I call it, per city and per state. So what this means is we have some collector widget out there that's just going out there and looking to see if there's a GPS point somewhere on Twitter that has something to do with Linux, and then they're just going to insert one or two or how many ever there were into the database, and we're going to make it do that in both a completely flattened way using documents, and then a completely not so flattened and very complicated way using MySQL. So the idea here, we're looking at a map. That's where the centroid would actually be the region. And then beyond that, we also want to see for the entire city, for wherever we're hovering over, what their statistics are, and then the same for the state. The information is, of course, purely fictional. Whatever. No, that was actually an extension to that slide. I wrote that in earlier.
They're pointing at like this and that for
Yeah, this is wrong. All right. So it's worth pointing out that this solution can be done fairly easily in both databases. That doesn't mean correctly. MySQL or any SQL-based solutions to this problem still require a lot of queries for something incredibly simple. And they aren't very... This whole solution is not very optimal as far as reducing the amount of queries, reducing the amount of tables that you use for object relational mapping frameworks like Django or SQL Alchemy. Are you guys familiar with Django, SQL Alchemy, stuff like that? Huh? All right, one or two. The goal of this comparison is to reduce the amount of queries it takes to get relative data quickly, and you guys are going to be kind of impressed. It's super awesome. Also, I wanted to show you some dramatically different query syntaxes that MongoDB offers above and beyond just SQL. It's not going to be that complicated. Most of it's just bullet items, but there is going to be some JSON encoded stuff here soon. How many of you guys know what JSON is? Right on. All right, so this is a very low-level view of how I would set up a very simple schema in MySQL to deal with this situation if I wanted to normalize all my data, which means that I only list the state once, and then that state has an ID, and then that's referenced in the city table. So we got the state table, state ID, state name. That's very simple. City table, city ID, state ID, referencing that other state's ID, or that other table. And then the city name itself. And then, of course, the region for the Twitter updates are actually going to be put. And here we're going to have a region ID, the city ID pointing to the city, and the state ID pointing to the state. And that third part there, that's an optimization, believe it or not, for making things a little easier later on. And then, of course, the region's name itself, and then the total amount of updates, which we're simply going to increment every time we see something pop into the database, or pop into Twitterland for a certain region. I think Scotty actually knows when I want to move on. Maybe I should give you the mouse.
I'm going to try it.
Maybe next time. I'm not really trusty with the mouse. See, it's just this, right?
Sprayed me earlier. It threw me off my ball.
So the MongoDB-based approach to this is much more simplified. However, it might not look like that in a few seconds, but it actually is quite a bit more simplified. We have an ID which references the document itself. The documents are per state. So what I'm assuming here is that for every region of every city in any possible state, I'm going to have a document that's actually relatively large, but very easy to get access into, to deliver to the framework that we're using. Instead of doing a whole bunch of query, does this exist, does this not exist? So I've based this model around the notion that I'm not actually going to have that many Twitter updates in individual regions, and that's okay. This can actually grow and get a little bit less optimal, but by golly, it will still be much more optimal than doing it through SQL. This is kind of a... We have the ID, we have the state name, and then right here, real quick, we have the total updates, which is completely added in as kind of a real-time incrementer that totals together all of the region names, or all the regions and all the cities totals into that one area. And we're going to update the totals for the state. And then right here we have the city names themselves as individual keys in this document. And then the total amount of updates per region for those cities. And then under that we have another sub-document, as they call it, that contain the region names. And then the total amount of updates for those region names. So everything is automatically aggregated as we insert the data in, and we do this atomically and through a single update. So
Does it add up total? Does it add one to total updates on every single thing?
yeah, and I'll show you this in a bit, but quite literally, when I say, hey, I want to add 1 to this region, this city, and this state, it will do it all in the same operation.
But it would limit it so that you couldn't just add an update to a city, but not to an actual update itself.
Well, I can do anything I want. That's the power of this.
Okay, so it gives you
The whole idea.
Yeah, the whole idea is when I want to update just a region, I'm also throwing totals in for the city and the state. Yeah. So the document and sub-document structure that MongoDB allows is really allows object-oriented database access through programming languages like Ruby and Python to have immediate access to information as well as modify documents in a way that can be quickly pushed back to the database server without much of a fuss. Actually, it's pretty amazing. So we'll just take that document, modify it in user space real quick outside of the database, and just push it back. No insert, no update, no if then else, no anything else. It's gone. You can map the result of each query, or find as they call it, into custom classes if you feel like. I actually have several Mongo document classes that I use that help me when I load documents in that I've fetched as a result. I load those into a class that then I then query and do extra fun stuff with. That's much more flexible than a dict itself, a dictionary type object. Actually, the source for that is on GitHub right now. So just go back to MySQL real quick. So the process of inserting this information into MySQL is really simple because we've normalized everything. To the completely savvy SQL professional who's normalized absolutely everything, all they're seeing here is, hey, all I need to do is update the total per region and not have to worry about a thing, because later on I can make a whole bunch of queries and get all that information out, and it's going to be this really cool obfuscated string, and no one but me is going to know how cool I am. And that's something I really wanted to avoid. Even if this more optimal, I'm still looking at tons of queries. So progressing on to MongoDB, upserting. This is kind of fun. Upsert is the capability to insert new objects or update them if they don't already exist, or if they exist. So if the state that I'm looking to update doesn't exist, I just made a new document with a very base skeleton that I can then build on top of. It's a very loose way of dealing with databases. So first, the state name, which is all part of one option, or one operation, which is called find and modify. I'm going to show you this on the next slide. And then I'm going to update the following fields. Total, which is the one that was in the base there that related specifically to the state. I'm going to increment that by 1. City name dot total. That's dot notation for you. We're going to have some fun with that. Especially since there's a space in there. These keys can have spaces. They can be completely Unicode, and I can separate them by dots. So that is then going to be incremented by 1. And then city name dot region name dot total is going to be incremented by 1 as well. If no match for a state name is out there, well, then we're going to create a document, and it's going to have 1 in every single one of those fields because they all started off as 0. What's null plus 1? 1, usually. Sometimes. Hopefully. So here's what this looks like. db.twitterupdates.find and modify. First, we're going to name our query. The query is state name is Alaska. That's us. The update, increment, and that's just one single operation. We're going to increment total. We're going to increment cities.anchorage.total and cities.anchorage.mountainview.total. There's that space for you. And then down here below, we're going to upsert it if it's if it doesn't exist. So query was basically my way of saying I want to find and modify this document, and the document I want to find matches state name Alaska. And I can also put find and modify with an empty query and update every single one of the documents in my database with absolutely no query in there.
Okay, so query pretty much just means like I'm updating this. Find this so I can update it.
Exactly. Okay. And hopefully it only returned one document.
I think the understand under the find and modify queries, find Alaska is a specific thing.
Right. I'm saying that I want to find. I mean, it's the wonderful thing about MongoDB is how freaking literal that is.
Yeah, right.
Find and modify. I can make this also update itself, but find and modify actually returns the new or the unmodified version of the document as well. I prefer using it that way. I can do some checking around just to make sure I got the right one, and maybe put on the brakes if I didn't. This is fun, guys.
So I assume there's some kind of locking mechanism.
You're looking at it. This entire update is atomic. So it locks this specific document actually at the collection level as of MongoDB 2.2. Otherwise, it was at the DB level in MongoDB 2.0 and lower. The parallelism that simple change allowed was dramatic. You can instead of slowing down a whole bunch of databases while you're doing atomic updates, you're only slowing down specific collections. And by slowing down, I mean like not really slowing down ever.
So is it only locking Mountain View?
No, it would be locking Twitter updates.
Oh, the whole
Yeah,
Twitter.
for the split second that it takes to write to the journal.
Okay. Right from the journal.
So let's take a look real quick at what that actually looks like. Ooh. Yeah, it's actually called Bison, BSON. It's a binary serialization.
So it's a binaryized JSON file.
Yep.
Okay, and then you can convert that into a JSON if you want to read it.
Basically everything. Well, this is where it gets a little difficult. The Bison representation of this object ID is quite literally binary. That object ID wrapper is only there because it needs to look pretty and not confuse us and kill our terminals. So what we've made at this point is this document. This is a brand new document. This could have been existing, but it has that automatically generated object ID that was generated at the server level. I can generate it locally if I want to. Just use some sort of UUID. And then it automatically created, due to dot notation, this cities container for another subdocument, or actually a lot of subdocuments, one of which being Anchorage. And then of that, Mountain View. And then there's your total. There's your total for Anchorage. Here's your total for the state document itself. I'm actually going to throw Hillside in here real quick and shrink the font. And what you're going to see here is that we've actually added a Hillside subdocument within Anchorage. We upped the total by 1 as well, and then the total for the state as well. So that's kind of how atomic updates in MongoDB work. If you want it, the concept of transactions in MongoDB is not necessarily there. In fact, the idea is avoid them at all costs and use very intelligent update modifiers in order to get the work done. To make this more atomic, there's a way to actually do a find and modify with an atomic variable set, which then locks a little bit more substantially. But what we're looking to do here real quick, and this does not necessarily matter for these documents, because any update is always going to be atomic when you're just working on one document, is what we're trying to avoid is a lot of things just summing things up incorrectly, which is actually really easy to do in SQL. What's going on? I think I'm just throwing away my things and just going with it. Okay, so finding the totals first. Okay, so you all saw what that document looked like. So now actually doing this in SQL, finding the totals for the state, city, and specific region in MySQL. First we have to lock the database. Then we have to select all the regions for the state and then total them up. So thankfully we have that extra reference that actually said this region belongs to this state. So we can actually total that up really easy. If we didn't have that, we'd have to first aggregate all of the regions for the city and then aggregate the city results into the state. It's a mess. And it's a ton of memory. Then we have to select all the regions for the city and total them up, and then select the total for the region and total them up. Or, well, that one's already totaled. And then unlock the database. And the reason we're locking this is because without that lock, well, we could actually have one of any of these change, and we wouldn't really know anything happened until the very end when someone filed in a bug report. This would specifically be, the lock would specifically be when we actually have the totals pre-aggregated in the state and pre-aggregated in the city. The reason I did not want to do that is because it was actually less optimal to do it that way. Now I'm actually doing queries, or when I do updates, I'm actually doing more and more and more updates for more and more and more tables, and I'm locking the database for longer and longer and longer each time I do that. There's still lots of applications to when we're doing this, there's still a lot of back and forth application to database movement that you really want to avoid. Like I said at the very beginning of this, what we want to do is be able to select that information in like one query and update it in like one query and actually info when we need it. If you were using an object relational mapper, wow, this would be interesting. It would be line after line after line of checks, balances, big ugly joins, extra tables that help relate the tables together. I don't even know how to really put this. It would just be a mess and completely unoptimal, which is one of the reasons I moved away from using Django and moved more into using different frameworks like Bottle, Tornado, and then just MongoDB, as well as some caching systems like Redis. There is no redundancy in this, so everything's normalized, nice and pretty, makes everyone happy. If I were to print this database out, it would probably cost me a whole sheet of paper for like 3 regions. MongoDB, that really wouldn't be the same. We'd have a lot of extra surplus information. But that redundancy really saves us a lot of headache later on. Now that data is cheap, storage is super cheap, I like taking advantage of it. Finding those totals for the state, city, and region in MongoDB is as simple as finding the document that has the key state name, and then checking to see if city name.region name exists in that document, and you're done. I really like it. So you guys obviously noticed the huge difference in between SQL and using MongoDB and document-related objects versus tons and tons and tons of rows.
Yes, you illustrated that quite well.
I like to be
but
thorough.
As technology experts, what I like to be is, objective about these sort of things, and I can clearly see that there's a lot more about the SQL version than the MongoDB version.
Mm-hmm.
Have you done empirical tests on similarly sized databases and similar queries to quantify the difference, or is it just that obvious because of the namespace and all the memory utilization we take in one versus the other that one's clearly going to be a winner?
So my specialty is typically always going to be research and development, and I have completely pimped the Python timeit module to give me a lot of that information. What I've found through using the timeit module is that when you're, at least on a platter-based system, and sometimes even on solid systems, when all of your information is located very close on the disk and readily accessible by one read, that wins. It doesn't matter if it's 2 queries, 3 queries, 4 queries, that wins. So when you're dealing with SQL-related situations, but you absolutely need speed, using a system like Ryuk, MongoDB, some of the other ones that shall not be named because they run on Windows only. Those are real keepers.
Same true for memory resident?
I'm actually going to get to that, sir.
Okay.
All right, so what we're trying to do here is make one call to dynamically create a new piece of data without a bunch of transactions. Then that's what we did using find and modify or update. Retrieve one big, fat, happy, easily parsed document, right? If we add an extra field onto there, going into the next part here, that's basically called the stamp or the last time it was updated or an incrementer of some sort, we can add that as part of the index for that information. Has anyone ever used multi-key indexes? It's where you have... got one. All right. Multi-key indexes are where I have that ID or that state name followed by another key. That's all stored in the index. MongoDB likes to store its indexes in memory as much as possible. So it in itself is not necessarily memory efficient if you're trying to save memory for your application. When it's on its own system, that is the correct approach. It uses up as much as it can to make everything as fast as possible. And there are limits to that. You can limit it as well. So what you want to do is cache the document if you have the option to do so, either locally within your web app. Most of the time you'll have a web app that serves out several requests. Keep that resident in your system and then expire it when you need to or when it changed. Or in Redis, which is a memory-based distributed key store. as a structure itself. That way you can easily query Redis just for that information, or as a serialized document that you can bring in again, serialize, and use in your object class. And then, of course, use the index-based cache for validation. If it was updated, clear the cache, fill it back up again, use it. Depending on the data stored in the document, this method is typically much faster than multiple SQL queries, like I just said. It's good stuff. And whenever there's a presentation like this, go home, try it out, get on Docket and say, this corner case, right? Let's talk about it. There is some really impressive ways to use MySQL, to use Postgres to handle this sort of situation. But like I said, most of the time you want to bring that into a system that doesn't really know what to do with it, unless you're developing it all by yourself. And that's kind of the focus with MongoDB, is you don't have a lot of those tools right off the bat, and the user is very well empowered to use the tools that they provide in order to give you a lot of the functionality you were looking to have completely abstracted somewhere else. Use multi-key indexes to see if the region exists at all without even retrieving the entire document is a huge thing that MongoDB brings to the table. With all of those indexes stored in memory, finding out if that region exists first before you start doing anything else. Say that you were hovering, okay, so you're in Google Maps or Google Earth, and you're scanning by, and your update frequency is set to 0. You're querying. You can actually do all of that in RAM before you actually stop for a second and say, oh, hey, let's pull up some data. And then there are a wide array of ways to create this document structure. The way that I did it, I'd actually shoot myself if I ever caught myself doing it, but it was just for the presentation. There's different ways to deal with that situation that work really, really well. And you just got to choose what works best for you. So I really encourage everybody to just go out there, download MongoDB if they're interested in database development at all. Try it out for a little bit. It's got geospatial queries that are limited, but they work well. And I use it in quite a few of my personal and professional products.